This video shows how to derive the standard form of the equation of a horizontal ellipse centered at the origin. Let's see, these are the fixed points, and this is our ellipse. This is the major axis, and this is our minor axis. And this is the center. Let us say that A is the length of the semi-major axis, B is the length of the semi-minor axis, and C is the distance from the center to a fixed point. An ellipse can be defined as a collection of all points in a plane such that the sum of its distances from two fixed points add up to a constant. So let's say this is the ellipse on the Cartesian plane. As stated earlier, the distance from the center to a fixed point is C. Therefore, we can say that this point would have the coordinate of negative C, 0, and this one would be C0. Let us choose point XY on the ellipse. What we're going to do now is to set up an equation that would represent all the points on the ellipse. Let us use a string to connect these points. Notice that as we move along the ellipse, the length of the string doesn't change, or it is constant. Let's say this is distance 1, and this is distance 2. Adding these distances would give us 2a. Remember that a is the length of the semi-major axis, and 2a would be the length of the major axis. Using distance formula, we can have this equation. Simplifying y minus 0 would be this. Rearranging the terms will give us this. To eliminate the square root, we can square both sides. And it will give us this equation. We got this by performing the square of a binomial for this side. Also, performing the squared quantity of x minus c would give us this. And performing the squared quantity of x plus c will give us this. We can cancel some of the terms, and we can have this equation. Rearranging the terms would give us this equation. And simplifying 2cx plus 2cx would give us 4cx. We can divide all the terms by 4. And it will give us this equation. Continuing, we can square both sides to eliminate the square root. And it will give us this equation. Again, we are doing square of a binomial for this side. Doing square of a binomial also for x plus c will give us this. And simplifying, we can multiply a squared to each of the terms inside, giving us this. We can cancel some of the terms. Rearranging the terms would give us this equation. Notice that for these two terms, the common factor is x squared, and for these two terms would be a squared. Let us divide all the terms by a squared times a squared minus c squared. And we can cancel some of the factors, leaving us this. In reference to this illustration, these sides have the relationship of a squared is equal to b squared plus c squared by Pythagorean theorem. Or we can say that b squared is equal to a squared minus c squared. Substituting b squared to a squared minus c squared would give us this equation. So this is now the standard form of the equation of a horizontal ellipse centered at the origin.